Today our lesson is going to be on probability and odds. First, I want to make sure that you understand the difference between experimental and theoretical probability. Let's start with theoretical. Theoretical probability is what we're usually looking at. It is what is expected to happen based on the possible outcomes, assuming equally likely events. So we're talking probability, and if you're not actually going through the steps of doing an experiment, it's theoretical probability of what should happen. Experimental probability is the result of an experiment or a simulation. So if you sit down and you actually roll the dice this many times to see what actually happened, or you pull cards out of a deck to see what actually happened, that would be experimental. But when you hear the term theoretical probability, that just means based on the number of events, what is expected to happen. And that's what we deal with most often. So to figure out probability, we're going to set up a ratio. And this ratio is going to be the total number of outcomes on the bottom. And on the top, you're going to have the number of ways that the event can happen. We're going to show how this works. It is important to note that in probability, it can be written as a fraction, a decimal, or a percentage. So let's look how this works. Your sock drawer is a mess. Can't imagine that. 12 black socks and 6 red socks are mixed together. What are the chances that without looking you pick out a red sock? First, you want to know the total number of socks that are in the drawer. It said that there were 12 black socks and 6 red socks. And 12 plus 6 is 18. So we know that there's 18 total socks. So that goes on the bottom of our ratio. Then you see what it's actually asking for. What are the chances that without looking you pick out a red sock? So how many of those socks were actually red? Well, it was 6. So that is the number that goes on top. So this was the number of red socks. This was the total number of socks. And you set up, it looks like a fraction or a ratio. Then you can simplify it. Both of these are divisible by 6. So that would be 1/3. It can be written as a fraction or as a percent, which would be 33% chance of pulling out a red sock. So my little PowerPoint will flip through it here. We had, okay, let's look at the next one. Your sock drawer is a mess. That's the same slide. I must have went backwards. Let's do that again. There we go. Your sock drawer is a mess. 12 black socks and 6 red socks are mixed together. We have the same scenario, so our total number of socks is 18, so that goes on the bottom. What are the chances that without looking you pick out a black sock? Well, this time on top we're going to put the number of black socks, which was 12. So you simply just write 12 to 18. 12 out of 18 chances that you're going to pull out a black sock, and you can write that as a fraction or as a percent or as a decimal. If you simplify 12/18, it is 2/3, and that would be 67% if you round it up to the nearest whole number. Okay, let's look at a dice. First of all, what do we know about a dice? A dice has 6 sides, so there's 6 different numbers that you can roll. What are the probability of rolling a 3? So there's 6 numbers on a dice. How many 3s are on a dice? There's only 1. So 1 to 6. And 1 to 6 you can write as a fraction or as a decimal or as a percent. So 1/6 as a decimal is 0.16 repeating, or that would be 16 and 66%. You could even round it to 17% if you wanted to round to the nearest whole number. If you're rolling a regular die, what is the probability of rolling an even number? Well, again, the number of sides on a dice are 6. How many even numbers are there? Well, 1, 2, 3, 4, 5, 6. 2, 4, and 6 are even, so there are 3 of them. So the probability of rolling an even number would be 3 to 6, but that is not simplified. So 3 to 6 is 1/2, which is 50%. Let's look at a deck of cards. You just need to kind of standardly know that there are 52 cards in a deck, and there are 4 different suits. So what is the probability that you'll be picking a king out of a deck of cards? Well, we know there's 52 cards in a deck. 4 suits, which means there are 4 kings. So that is 4 to 52. And then that can be simplified as well. And that would, whoops, went too fast there. 4 to 52 can be simplified to 1 to 13, which is 7 6/10%. About an 8% chance that you'll pull out a king. You're visiting a kennel that has 3 German Shepherds, circle 3, 4 Labs, 2 Chihuahuas, 3 Poodles, and 5 West Highland Terriers. When you arrive, the dogs are taking a walk. What is the probability of seeing a German Shepherd first? We need to know the total number of dogs. There was 3, 4, 2, 3, and 5. So I think that is 17 dogs. So that is the bottom number of our ratio. And then it talks about the probability of seeing a German Shepherd. And a German Shepherd was 3. So 3 goes on the top. So we have 3 to 17 as our probability. And 3 to 17 as a percent is 17 6/10%. 3 divided by 17. 4 letter tiles, one of each letter of the English alphabet, are placed face down on the table. What is the probability that you will draw a vowel? There are 26 letters in our alphabet. How many vowels do we have in our alphabet? A, E, I, O, and U. 5 vowels. So that would be 5 to 26. So what is the percentage? So that would be a vowel. 5 divided by 26 is 19%. Okay, now we're going to look at odds. Odds works a little bit differently. Odds sets up a ratio, but you put the favorable outcomes on top and the unfavorable on the bottom, not the total. In probability, we were putting the total number of possibilities on the bottom. We do not do that with odds. With odds, we put the unfavorable outcomes, ones that cannot be what we're looking for. So let's see what that looks like. And odds are only written as a ratio. Your sock drawer is a mess. Again, we have 12 black socks and 6 red socks, so we have the same scenario we had before, but this time it says, what are the odds you will pick out a red sock? On top, how many are red? What are the favorable outcomes? There were 6 red. And on the bottom, what are the unfavorable outcomes? There were 12 that are not red. So these are the red. These are the not red. Favorable, not favorable. So it is 6 to 12, and 6 to 12 can be simplified to 1 to 2. So odds works differently. You're not going to turn that into a percent. You're just going to say the odds are 1 to 2. 1 favorable to 2 unfavorable. You're rolling a regular dice. What are the odds of rolling a 3? So how many can be a 3? 1. And then on the bottom, how many are not a 3? Well, there are 6 sides altogether. One of them a 3. 5 are not 3s. This is called the unfavorable. So up here, these are our 3s. These are our not 3s. Favorable to non-favorable. So our odds are 1 to 5. And we just say 1 to 5. We do not turn that into a percentage. You're randomly choosing a card from a deck of 52 cards. What are the odds, not probability, you have to be careful reading, what are the odds that the card you pick will be a king? Well, how many kings are there in a deck? There are 4. How many of the cards are not kings? We would have to go 52 minus 4, and that would be 48. So the odds of it being a king would be 4 to 48. And you can simplify 4 to 48 just like it were a fraction. So 4 to 48 would be simplified to 1 to 12. It's a ratio, so we read it 1 to 12, not like a fraction. Here's the dog kennel example. 3 German Shepherds, 4 Labrador Retrievers, 2 Chihuahuas, 3 Poodles, 5 West Highland Terriers. What are the odds of seeing a German Shepherd first? So how many are German Shepherds? There were 3. How many of them were not German Shepherds? I think there were 17, so that would make 14 that are not German Shepherds. So our odds are going to be 3 to 14. Letter tiles. One of each letter of the English alphabet are placed face down. What are the odds, not the probability, that you will draw a vowel? So how many are vowels? 5. How many of the letters of the alphabet are not vowels? 26 minus 5 is 21. So our odds would be 5 to 21. So the difference between probability and odds. Probability, you put the favorable on top, and on the bottom is the total. For odds, you put the favorable on top, but you put the unfavorable, those that are not, on the bottom. So it's this bottom number that's going to be different between probability and odds. To figure out the odds of an event happening, oh, we already did that. I don't know why it's at the end of the slide again. It's not going back through again. We're going to stop right there. I hope you understand the difference between probability and odds.